let's look at profit. So I just wanted to mention, I was thinking about this number, and it makes a lot of sense that it's hundreds, thousands, millions, billions, trillions of dollars worth of farmable land in the United States. That actually does make sense to me. Let's talk about profit. Price that a company sets for their product is based on the model price per unit is equal to 6 minus 0.02x, where x represents the number of items made and sold each day. Revenue, that's money coming in, is calculated by multiplying the price of the product times the number of products sold every day. Okay, like it's worth $2 and you just bought 12 of them, so you just gave me 24 bucks. So multiply the price times how many are actually sold. The company's cost equation has been modeled as cost is equal to 100 plus 2.4x, where again, x represents the number of items, well, that would be made every day, yeah? The cost, price, and revenue are all measured in dollars. Of course. Oh, okay. La-di-da, thank you very much. As opposed to like thousands of dollars or whatever. Got it. Find a function to model the revenue, so the money coming in. Call it R. Sure. So what is it? It's the revenue is calculated by multiplying the price. Ooh, that's a function here. Times the number of items sold each day. That's X. X represents number of items made and number of items sold each day. Got it. Okay, so I think I understand what they're asking of us. They are saying there's a price model. Price is 6 minus 0.02 x's. And revenue is, let's see, price times number sold each day. So price times number of items, that's x, and that's this. Okay, so x equals number okay, so they're saying multiply these two. So P revenue is equal to 6 minus 0.02 x's times x. Okay, well, we're going to have to actually distribute, because that would be 6 times the x and negative 0.02 times the x. Okay, so revenue is actually 6 x's minus 0.02. Well, an x by x is an x squared. Got it. Okay, so there's our revenue. Knowing that profit is revenue minus cost, write an equation for the profit of this item's production. Call it prof. Okay, so profit is revenue minus cost. Okay, here we go. So the revenue, I'm going to write that down. Revenue is equal to 6x minus 0.02x squared. And cost is up here. Cost is equal to 100 plus 2.4 x's. Okay, so the profit. Oopsie. In terms of knowing how many we are making and selling of items. Revenue, take away cost. I'm going to start with the squares. So we have negative 0.02x squareds, and there are no x squareds to take away from here. So we're just left with that. Negative 0.02x squareds. X's, though, we have 6 x's and we take away 2.4 x's. 6 minus 2.4 of them leaves us with 3.6 x's. Now there is 0 non-X's in the revenue terms, but we have to take away this cost of $100. So remember that this 100 is not going to be positive. That won't increase our profit. It's a cost. So this is minus 100. So there's kind of this implied 0 that is happening, right? And also in this cost equation, there was an implied 0x squareds. Yeah? So 0 take away 100, negative 100. Negative 0.02x squareds plus, or take away 0x squareds, well, same amount. So here's our profit equation. Find the x-coordinate of the vertex, because notice it's a quadratic, and we just learned about those. So, quadratic. Got it. Find the x-coordinate of the vertex of the profits. Quadratic. Okay, so what was that formula? Opposite of b over double the a. Opposite of b, so negative 3.6, and double this negative 0.02, negative 0.04. How many times does that go into that? So negative 3.6 divided by negative 0.04, and I get 90. Ooh, 90, whatever this product is, we need to, right? Because that's going to be our peak profit, right? So that should be the number of items made and sold each day. That should be our goal in order to maximize our profit. Find the profit associated with the x-coordinate you just computed. So when x equals 90, the profit, and now we have to put in our 90. So negative 0.02 by 90 squared plus 3.6 90s, or 90 times, minus 100. And this is, as they say, in dollars, of course. So calculator business, negative 0.02 times 90 squared plus 3.6 times 90 minus 100. I get $62. Per day though. Okay, so that's our profit per day at our peak. That's our best our profit can get. Write down what the vertex means in the context of this situation. Okay. So, the most profit that can be made is $62 per day. That happens when 90 items are made and sold. There we go. That's our peak performance right there. What should the company price this item in order to maximize their profit? Okay, so remember we just said x equals 90. So to maximize their profit, when x equals 90, that's what was happening. Hold on, right? That's the max here. And if we look back up here, it says the price is 6 minus 0.02x. Let's use that. P equals 6 minus 0.02, and then in replace of the x, because we're saying when x is 90, I'm going to put the 90. 6 minus 0.02, 90 times 4.2. Okay, what should the company price this item? $4.20. That should be the price of this thing. If the company is currently producing 100 items per day, should they increase or decrease production? They need to decrease production because they should be making 90. So ironically, everyone's like push, 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 but they should be decreasing in order to make the amount of, so decrease by 10 per day. Yeah, slow it down a little bit. Let's suppose the company donates the proceeds from 10 sales each day to patients needing to be on dialysis. It's quite a popular need. It's expensive. Instead of X units included in their profit, now there will be X minus 10 units included in their profit equation. Find the new function to model the company's revenue. Okay, let's see. So let's go back and see where we had an X, and now we need to replace it with an X minus 10. Their revenue is not going to be, this is not how much money is going to be coming in, because that's for X units sold. And now they're only going to be, the money coming in, it's going to be X minus 10 units sold. Okay, so we're going to need to adjust our revenue. So find the new function to model the company's revenue. Okay, so the profit is going to be affected because the money coming in is going to be affected. So let's go ahead and figure that out. So the revenue is going to be the price, 6 minus 0.02 x's, times however many get purchased. But that we are only going to consider X of them, but minus 10 of them, because that's what we're going to donate. Okay, so that won't be part of our money coming in. That's going to be part of our money going. So, okay, here we go. Let's do it again. Whee! I see 6 x's minus 60 minus 0.02 x squareds, x by x, remember, and a negative times a negative is a positive, plus, oh man, what is that, 0.2x? I think so, because 10 hundredths, 10 hundredths makes a tenth. So let's see, and I'm just going to rewrite this in descending order, negative 0.02 x squareds. I see 6.2 x's, and now minus 60. And now that will be our revenue. Okay, let's see, so find the new function to model the revenue. Got it. What kind of impact will this donation have on the maximum profit? So now we're going to have to find the profit because our revenue, our money coming in, just got changed. Profit. So first, adjusted profit is revenue minus cost. And revenue, we have a new equation for that I'm copying. And remember the cost equation, going back here, cost equation was 100 plus 2.4 x's, and we said plus 0 x squareds, really. So 0 x squareds and 2.4 x's and plus 100. So I just put it in descending order just to help myself line this whole thing up, because that means our profit equation. So we have negative 0.02 x squareds, take away none. So negative 0.02 x squareds. Remember, we're subtracting. 6.2 x's, take away 2.4. So 3.8 x's. And then negative 60 minus 100, because remember this is a cost. So minus 160. And it says maximum. That means we need the vertex. Okay, so vertex x is equal to the opposite of b over double this a. Negative 3.8 divided by negative 0.04. Okay, so now it's going to take us 95 units to be made and sold in order to maximize our profit. And let's compute how much that will be. So profit instead of price, the profit, and I'm going to plug in 95 into here. So negative 0.02. Okay. Negative 0.02 times 95 squared plus 3.8 times 95 minus 160. 20.5. So now the profit is $20.50 per day. Oh, that had a really big impact. That is a very generous donation. So we have to produce and sell 95 items per day, and our profit per day, the maximum profit we can make if that happens, is $20.50 per day. All right, quick summary. Polynomials and quadratics. So sometimes we see linear correlations. Okay, sometimes even when we multiply two lines, we get a quadratic. So we have a lot of, second order, or where the highest exponent is 2 applications. And then sometimes they're even higher than that. Yes. We add, subtract, and multiply polynomials in order to actually apply them to situations. And we also graph and use the graph to find values from time to time. So even though we maybe didn't explicitly do that, this was all based on the graph, yes? And we saw two pretty good applications where this is definitely used.